Support for Lab Out Loud is provided by NSTA, the National Science Teaching Association. Find out more about what NSTA has to offer at nsta.org. You're listening to Lab Out Loud, Science for the Classroom and Beyond. And today our guest takes to the sea to study invertebrates.
I personally love invertebrates just because they just look so weird, and that's initially what drew me to working as a marine biologist. And I'm interested in when they're on the seafloor, what are they doing? So we do send lots of equipment down to the bottom of the seafloor to take samples, and then when we bring that sediment and the mud back onto the ship, that's when we can collect our samples and run experiments back in the laboratory on the ship.
That's up next on Lab Out Loud, but first I'm your co-host Dale Basler.
And I'm Brian Bartel.
Hey, last podcast of 2020.
Yeah, and
goodbye 2020.
Goodbye 2020. And don't let the door hit you on the way out.
Yeah, no kidding.
We're actually closing off the year with our first Scientist Out Loud episode of this season. We had a lot last year, and we're starting to pick that back up. We have a couple others recorded there. So
I didn't even realize this was the first one. Let's explain to listeners what our Scientist Out Loud series is.
All right. So last year, before last season, I had gotten into a list of scientists on Twitter called Science Twitter, and I basically asked if any of them would like to come on the show. For a while on Lab Out Loud, we definitely focus on recording episodes that we think teachers will enjoy or they'll benefit their own practice from listening to. However, sometimes there's things that we want students to listen to as well. So some of this came out of that thought that we want some episodes that teachers might be able to have students listen to about scientists in the field, how they do their work, how they got involved, why is their work important, that kind of thing. And it's gotten some really great conversations going about what's actually happening in the science world of careers.
Yeah, what do scientists actually do? What's their life like? They're real people, that kind of thing. In the olden days, and maybe still, your textbook would have like a little insert. But you remember the textbook would have a little insert page, and it would be like careers in science, and it would just be like some rando person is like,
and always in the lab, always.
Yes. So
Which
this
definitely is
this is the audio version of that, where we get to talk to one of those actual people, ask them questions, and also learn a little bit about their life too. Because unlike the textbook, those textbook pages were always very one-sided. This is what this laboratory person did.
Right. And we don't have to worry about making sure they have lab goggles on if they're doing research or anything, because it's audio, right? But yeah. It's been fascinating to listen to, because we also learn that a good chunk of a scientist's job isn't always field research. It's a lot of sometimes just behind the desk work as well.
Yes. Our guest today is Dr. Rachel Hale. And she is actually living in New Zealand. Talk about that. We're going to talk about that in the interview with Dr. Hale. She is in New Zealand. They are living the dream over there, because if you're thinking pandemic, they're in a little...
well, they're practicing their science.
Time-wise, they're in our future, because they're ahead of us in the hours, and they're ahead of us because they're a little more isolated, and then they've been able to control the pandemic. So
yeah, but they've taken good science and practiced it. And I think that we can see that in Australia as well, where yes, it is a little bit isolated also, but it's a lot bigger. It's not as small of a country that way physically. And so, here's a couple of countries that have taken the science, practiced it, and are doing pretty well with it.
Yeah, listeners, try not to drool when Dr. Hale talks about, no more lockdowns and those kinds of things. But what we should mention is that this interview was done on November 8th. So we'll refer to some things in the show that are a little bit back in time. But let's not wait any longer and welcome Dr. Rachel Hale to the show.
Hey, so I'm Rachel Hale. I'm a marine biologist. I have a PhD in environmental science, and most of the time I can be found working on either big research ships looking at sediment from the deep sea, or working on the small boats that we run out of Nelson here in New Zealand and looking for small animals that live around our coastal zone.
And actually, we've been trying to get you on the show for a little bit, and the last time we tried, you said, I'm going to be on a ship shortly. So you were just on, you called it a cruise, I believe, or I can't remember exactly what you called it, but can you tell us a little bit about that experience? What did you do there? What does that entail?
Yeah, so I think I called it a research cruise, which makes it sound a bit more cushy than it actually is, although the ship is very comfortable. But yeah, so I should probably call them research voyages. But
that still sounds fanciful.
Yeah, it does, and I really enjoy going on them. It's a really fun time. You get to spend a good 2 to 3 weeks really focused on your science and working closely with other scientists who are on the ship, and you're all doing something that you absolutely love, studying the seafloor and the creatures that live there and the mud and sediment that's down there. And yeah, it's just a really enjoyable time working with people who are really passionate about what they're doing.
Where does the voyage start, and where does it start and travel to and return to?
So the voyages that I've been going on in New Zealand, they have left from Wellington, obviously the capital of New Zealand, and they're mostly run out of our main office that's also based in Wellington. And I've been on a couple so far in New Zealand, and the last one went to the Kaikoura Canyon, which is this big canyon that runs off the east coast of the South Island in New Zealand, and it's a really important place for biological productivity and biogeochemical cycling.
So are you deep in the sea, or can you still see New Zealand? Or are you far out there? Give us a view of what it looks like from the ship.
Yeah, so it depends on what we're doing. So the last voyage, we were quite close to shore, so we could see, it was beautiful. We could see the mountains on shore and the snowy peaks. But usually we would go quite far out and you're just surrounded by ocean. You can't see any land at all.
Wow.
Was that unsettling? I imagine you've done quite a few of these voyages now. Are you used to it, or did that take a little time to adjust to?
Yeah, for me, it took a little time to adjust to. So for the first voyage I went on was about 7 years ago. And yeah, it was different. And it was unsettling to completely leave land. You feel like you're kind of leaving the safety of your territory. But as I say, the boat's really comfortable, and we sail with a really knowledgeable crew and captain. And now I just love being out there surrounded by the ocean. I really miss it when I get back to land.
What do you need to do to prepare for a voyage like this? What does that all entail?
So it takes a lot of quite intensive packing, because obviously once you've left, you're committed and you're out there, so you can't come back. So you basically need to make sure that you don't forget anything. So I tend to run through every process and every experiment that I'm going to do on the boat a couple of times in my head to make sure that I'm not going to forget anything, and to make sure, you're taking hundreds of vials to take seawater samples, but if you run out, you can't take any more. So I always end up packing twice as much and a little bit extra just to make sure.
Have you or a fellow scientist ever forgotten something like that, or a personal item, or?
Yeah, there have been
Somebody
a few people.
got a toothbrush?
Yeah. There have been a few people who've forgotten some personal items exactly like toothbrushes or toothpaste, but there's normally enough people on the ship that have brought enough spares of things like that, and the crew are very used to perhaps some slightly more inexperienced scientists joining the crew that might forget things like that. So they have sometimes they have a little stock on board, and everyone takes a bit of extra equipment for everyone else. So everything's normally covered, and you get quite good at improvising as well.
Okay. How big of the crew? How many people are on the ship, the crew, and then how many scientists?
It depends on the ship. So they're different sizes, but there can be about 25 crew and 25 scientists, or up to 30 crew or 30 scientists. on the big ones that are about 75 to 100 meters long.
Wow. So you really guys, you get to know each other quite well.
Yeah, you do. Yeah. Good friends.
Yeah, I bet. And how long are the durations of the trip?
They can range. So I think the shortest one I've been on has been about 10 days. And that's quite nice in that you're headed out and you know it's quite short. So you come back in fairly quickly. But then when you go out, you can go out for 3, 4, or some of them even go out for 8 weeks. And that's when you really have to kind of get into the mindset of being on the ship for a long time. You kind of get in a rhythm. And you have a very structured day-to-day life where you're doing your 12-hour shift, and things revolve a lot around meal times as well. So the food is always really good on the voyages as well.
Okay. Now let's talk about the science on board or off the ship. Are you getting off the ship to do any collections? What does that look like?
So we don't tend to get off the ship once we get on board, but we do send lots of equipment down to the bottom of the seafloor to take samples. So we take sediment samples from different depths, can range from 100 meters to, up to 4,000 meters, depending on where we're working. And then when we bring that sediment and the mud back onto the ship, that's when we can collect our samples of sediment, when we collect the organisms that we might be working on, or when we collect whole sediment core samples and run experiments back in the laboratory on the ship.
Okay. That a lot of it probably you take back with you as well to do more analysis on, or can you do most of it on the ship?
So a lot of the samples go straight into the freezer, or the organisms can be preserved for identification and study, taken back to land. Yeah, so quite a lot of the samples are taken back to land. But we do run some incubations, and there's some immediate data that we can collect on board the ship as well.
I looked at your Twitter feed. Brian shared it as soon as we had the interview booked, and it's twitter.com/seafloor science. Perfect name
Thank you.
For this. And I have to say, the pictures, it looks like you are visiting alien worlds in some of these photographs. They're amazing. Now, there's a bunch where you're just covered in mud. It looks like that is a part of your job, getting kind of dirty and into the mud.
Definitely. Yeah. I guess that's one of my favorite parts. I never really grew up from the whole playing in the mud and playing in the sandpit and messing around kind of phase.
Okay. And then some of these photographs of some are underwater. They look like samples, just creatures I'm not familiar with. I don't know. Tell us what we're looking at here. There's a whole variety of things, but what ultimately are you studying from those samples from the seafloor?
Yeah, so what I study is mainly centered around the diversity of invertebrates that live within the sediment and live on the seafloor. I personally love invertebrates just because, as you say, they just look so weird. And that's initially what drew me to working as a marine biologist. And I'm interested in when they're on the seafloor, what are they doing? So one thing they can do is, it's called biotubation. So biotubation is a really important process that helps oxygenate the seafloor, and it can support loads of other smaller species called myofauna that live in the sediment, and also the microbial flora that live in the sediment as well. And these are all really important for biogeochemical cycling, so nutrient cycling of carbon and nitrogen within the seafloor, and that helps support all our fish stocks and things like carbon sequestration, and it can be really important for essentially kind of global regulation and things like climate change as well.
Is there a particular reason you're in New Zealand to do these studies, or is that just where you live, or how did that become?
Yeah, so I did all my training back in the UK, and then I was working as a postdoc back in the UK as well. But I saw the job advertised in New Zealand, and I'll be honest, one of the things that drew me to the job was that it was permanent. So I was working on a series of temporary contracts, as is pretty usual in science. But also, like, New Zealand is such a special place because it is so far from everywhere else. It does have a really unique and distinct set of animals and plants living here. So from a biodiversity point of view and a scientist point of view, it's a really interesting place to come and work. And having arrived not so long ago, I'm still kind of in the phase of learning about all of these cool new species and being exposed. So it's kind of like discovering all the cool new invertebrates and species all over again, like I did when I was a kid.
Is there something that New Zealand has that essentially makes that location perfect to study the global climate change, rest of the world, those kinds of things? Like, I guess what I'm asking is, the research you're doing, can it be done in many, many locations all over the world, or is there something in this particular region that is part of the reason the science has brought you there?
Yeah, I think the science that we're doing in New Zealand can be transferred to any part of the world, but I think because there's not so much population living here in New Zealand, and because we've got a huge seafloor area that we can access compared to the level of population. There's actually so much of New Zealand that hasn't even been studied yet, and loads that we don't know about some of the processes that are happening in New Zealand. And we also have kind of these unique areas, like there's the White Island with the volcanic vents, and the Kaikoura Canyon that I mentioned earlier. There's a really important and really biodiverse area of the seafloor here. I think there's a lot of unique aspects that just come together in New Zealand, and there's just a lot of potential, and it's exciting to see the science that's being done here.
You mentioned that some of your work might tie into investigating climate change, and one of the questions that I wanted to ask you all along is why should we care about your work, or what matters about the work that you do? Why should students think that this is important to learn?
Yeah, and I guess that's the big question, isn't it? So I'm interested in the biodiversity of the seafloor and what that biodiversity is doing. So essentially, if you have a worm that lives on the seafloor, and as it moves, as it feeds, it creates these burrows. And these burrows are really important for helping oxygen enter deeper into the seafloor than it would do. So if you imagine you've got just a flat seafloor, if you then have a burrow that's sticking in the middle of it, you've greatly increased the amount of oxygenated area that's happening there. And these areas are really important for microbial cycling. And just the fact that you have so many worms, you've got shrimp, crabs, everything just mixing the sediment and doing lots of activity on the seafloor, the more diverse animals you have and the more abundant animals you have, the more of these processes are happening, the more microbial growth is supported. And these small changes, like just the creation of a burrow, if you have lots of it going on at once, these can create a huge change in the processes that are happening.
It kind of reminds me of, like, here in the States, we have like lawns, big grass lawns in front of our houses. And sometimes we'll hire someone to aerate it with like these little fingers that just dig little holes, rolls through it. And
like almost little drills.
Yeah, I think that's
what they are, I think.
A mechanical way of doing what we're trying to do to the seafloor, or am I reaching for a parallel there?
In the same way that you would aerate your lawn by putting a hole in it, just imagine that you've just got a load of worms and they're doing that process naturally.
I should get some more worms then.
Yeah.
Kind of a natural
Everyone
way.
should.
Well, you have there's a lot of pictures of worms in your feed. Is that, do you have like a favorite like introduction line about I'm Rachel and I'm into worms, or how do you introduce yourself at parties?
Yeah, unfortunately, that's probably fairly accurate. So, for a long time, I've kind of been known as Worm Girl in my circle of friends. Yeah.
It's a different superhero.
There could be worse things. I think that I'm amazed by some of the pictures here. I even see some bioluminescence, and you must have seen some fantastical creatures as well. What's one of the? Can you tell us about something that just blew your mind?
Something that blew my mind recently was, so I didn't see it. It was some pictures from some divers that were diving off White Island in New Zealand, and they saw this huge pyrozome, and I think it was about maybe 10 meters long and maybe a meter wide, and it's this long kind of sock-like body that's made up of all these colonial organisms. And yeah, that really blew my mind. I didn't know that they could get that big. That would be my dream, to see one of those. That would be awesome.
So you really do have a bucket list for some.
I've definitely got an invertebrate bucket list. Yeah. There's a number of species and a number of New Zealand specific species as well that I'd really love to see. One of those is the velvet worm as well, which is a terrestrial only worm phylum. And there's some down the road, and I need to get my act together to go and find these velvet worms. They're so cool.
Velvet worm sounds like some sort of punk band.
Is this something that you can easily find, and you just haven't taken the time to go look for them, or you're going to have to, do some studying and get some gear for this?
No, so I'm just waiting for the right kind of weather conditions, and when I can head over. There's a couple of hour drive. So I'm just waiting until I can head over. But I think you have to be lucky to find them. They're quite rare, but they do just live under logs. So if you're careful, and obviously make sure that if you turn anything over, put it back as you found it. But yeah, I'm hoping I can just go over and turn over enough logs gently to find some.
My dad's an amateur photographer, and mostly for birds. So it's like he's got this bucket list of. I think he said he did like. I got like 7 of the native species of honeybees in Wisconsin or something like that. He's on a
wow.
He's got his goals there, but he often comes to our area because snowy owls come to our area, and he's checked that off his bucket list many times. But nice. For some people, they haven't seen that at all.
Yeah, I definitely have an invertebrate goals bucket list. I think we all do. Everyone on the voyages is waiting for like that spectacular creature to come up.
I was going to say partly our bucket list, we cross off countries and locations for podcast guests. And I think you are the first from New Zealand, right, Brian?
You are actually, and you are the farthest away that we've ever had. In fact, you are into tomorrow from where we are right now.
Yes. It's the night.
Not only physically, but temporally farthest away from us.
It's going to be okay. It's a good one.
Oh, great.
Monday's
Perfect.
Good? Is what
Monday's
you're telling
good.
us? Okay, good.
I was telling I have teenage kids, and I was like, yeah, I'm going to go talk to the guest today, and she's going to do the podcast on Monday, but I'm doing it today. And I was waiting for them, and they're like, let me guess, she's in Australia? I was like, close, and then they picked it right away. So,
can you tell us, Rachel, how has your science been affected by the pandemic? If I look through your Twitter feed, there's, I love seeing these, like how far away should you stay from people? What is the social distance norm? And yours is an image of one sand striker worm away. Now that's probably hard to do on a research vessel, but how has the pandemic affected your work and your science?
Yeah, so initially when we went into lockdown, our fieldwork was cancelled. So we had a lot of fieldwork that was planned locally in just our small boats. So unfortunately, we had to postpone that. And I had another research voyage that I knew was coming up. And we wouldn't have been able to go on the research voyage if the pandemic had stayed as bad as it initially was in New Zealand, if we were still locked down. Thankfully, we managed to get down into what we were calling level 2. But we still had some protocols that we had to follow when we joined the research ship. So we were still doing a bit of distancing and hand washing, and we had separated meal times on the ship, so only half of us would eat at once, so we could maintain distancing protocols. But it is difficult to maintain distancing, obviously, while you're trying to work and you're passing sampling equipment to each other and passing sediment samples to each other. So that would have been quite difficult. But I guess one of the benefits to going away on a research voyage is that because you are together for so long, once you've kind of incubated together for 2 weeks, you kind of know no one else is sick.
That's true.
So you are your own little bubble from that aspect. And then when you come back to land, you obviously have to rejoin everyone else. So it feels a bit strange. All of a sudden you're interacting with a load more people when you're used to only being with about 40 or 50 people on the ship.
Absolutely.
But New Zealand's become their own little bubble when it comes to the pandemic, correct?
Yeah, we have. Yeah. So we don't have any restrictions at the moment. We occasionally obviously we have cases that are coming in from overseas, and we occasionally have a few cases that pop up from contacts that might have happened from those cases. But I think the system that they've got in place at the moment is pretty good at picking those up and also isolating everyone involved. So at the moment, we are pretty much normal, which is awesome. I feel very privileged to be here and to be able to continue working.
We're pretty jealous, actually.
Yeah, definitely. Envious. How exciting.
Yeah.
What are you learning? Like, is there something in your time doing the science that you've learned, sort of conclusions from the research?
Apart from the fact that I constantly learn that there's new stuff to learn. Yeah. Like for me personally, it's always what the data can tell us. So sometimes when you first look at the pattern that you're seeing, it can be not obvious. And if your experiment hasn't worked, you might be a bit disappointed. But there's always something interesting that you would be able to find. And the fact that that's not always obvious really interests me. Like it's a puzzle that you have to put together. So yeah, I'm always learning more about my study system and unexpected things that can happen.
So every day is sort of a mystery then.
Yeah.
And how did you wind up along this line of work? I mean, particularly we think about this subject as we have students that listen. When you started off in school, when you were maybe the students that are listening their age, were you destined to be on these, research voyages, or, can you tell us about the path that got you to this position?
Yeah. So I didn't really see myself probably working in the area that I do work now, but I did always know that I wanted to be a marine biologist. Like that was what I wanted to do from the start. And I was
What drew you to that?
Sorry?
What drew you to that?
Yeah, I was always fascinated by invertebrates. It was literally walking along the beach as a child and rooting around the rock pools and looking at all the weird worms and shrimps and crabs that I would find, that just made me want to know more about what these animals were, what they were doing. Why did they look so weird? Why do crabs have claws? Why do they look like that? Why are their eyes on stalks? Why do the worms burrow into the sand? And I just wanted to know more about these cool animals, like you say, exactly like trying to study little aliens. I just think that's so interesting, and I just wanted to know more and more. And every time I had to make a choice, I guess, for my future career, I based it on how do I find out more about this.
How do you deal with invertebrates that, let's just say, invade or come close to you in your living spaces? As I'm looking at an Asian lady beetle that has made its way into my home.
Oh, they have been everywhere right now.
It's the weather right now that has that happen, but
yeah, I have to say that there are some animals that I'm not fond of, but I mean, most of the time we're invading their space, right? So
good point.
True.
But I guess when I see big spiders in the house, I do gently relocate them. But we do have a lot of house guests that we live with on the regular. I tend to leave most of the spiders alone.
Well, spiders are good. And the bugs in my home and the insects provide hours of entertainment for our cats. So there's that. I mean, they serve a role there.
And entertainment for you then, I suppose, Brian.
Oh, it's fascinating sometimes, especially when there's one on the ceiling and we see one of them losing their mind. It's kind of fascinating to think about what is going through her head that she's just so fixated on this little animal. Well, Rachel, before we let you go, we are going to have students that are listening to it right now, thinking about their careers ahead. Maybe they're interested in science. Maybe they have a worm destination ahead of them, or maybe they're thinking about other things that they want to do in science, or maybe they don't. They just know that they want to do something with science. What advice can you give to them as they're thinking about preparing the way for their future?
Yeah, I would just say follow what interests you, because that's what you're going to be the most passionate about, and that's what's going to drive you. If there's something that you want to know more about, then that's what's going to push you forwards, and that's what's going to take you into a job that you really enjoy.
Thanks for listening to this episode of Lab Out Loud. If you'd like to learn more about some of the things discussed in this episode or previous episodes, you can find show notes at our website, laboutloud.com. If you have a guest idea or a future topic that you'd like to see on Lab Out Loud, go to our contact page and send us a message. Also, you can subscribe to Lab Out Loud on your favorite podcasting app, such as Apple Podcasts, Spotify, Stitcher, Google Play, or wherever you like to find podcasts. While you're there, leave us a review and rating. Your input helps others find our show. Thanks again for listening.